Okay. So to figure out number 18 on our lab here, we're going to take 0.52 plus 0.59, oops, 0.59 plus 0.47 plus 0.33 plus 0.33. Make sure I added those up because I always end up hitting the wrong button somewhere. Did I do those right? Do I hit divided by 5 or do I hit enter? Enter. Then divide by 5. And I get, for mine, I get 0.45 roughly, right? If we round it off to the 100th like we were doing. So on the next page, for problem number 19, I'm going to write 0.45 right here. All right, this is what I want you to tell me. What did you get? What did your group get?
0.64.
Point what?
64.
64. Huh. That is odd. How about you guys in the back there? What'd you guys get? 0.6. I'm gonna put 0.60 just for all the same. What'd you guys get?
0.38.
0.38. This is a class of extremes here. How about you guys? What'd you get? 0.63. All right. And how about you guys? 0.45. Okay. I'm not going to say you guys are weird, but that's weird. And here's why it's weird. What did you expect to get? 0.5. Didn't everybody expect to get 0.5? Because just like yesterday, it's either a heads or a tails, right? So we should all have gotten 0.5. We obviously didn't. But let's do this. Let's find an average of the averages. So do this on your calculator. Add all these numbers up. You can, oh, I'm sorry. There we go. Sorry about that. These are the numbers that we were supposed to. These are the numbers I got, and these are the numbers you guys got. I want you right now to figure out the average of the averages. So add all those up. Make sure I typed all those in right. And then divide by how much? 1, 2, 3, 4, 5. I realize this is honors class, but that's 6, right? Okay, not 5. So hit the enter button and divide by 6. What does it say? 0.525, which would round off yet a 0.53. So listen, even though you guys are a very odd class because you're getting all these crazy numbers, something called the law of large numbers says that even if, now, is it possible that Foster's group messed up? It's not possible. Foster never makes mistakes. But is it possible that they actually got 0.64? It's possible. I have my doubts, but it's possible. No, I would never. You guys, I'm sure, totally did it right and didn't make any mistakes. But the law of large numbers says, and this is why I think they didn't mess up, because even though they got 0.64, why did I think that was so odd? Because you should have got 0.5, right? And they were way off. And this team here was way off, but this team was way off in the opposite direction, right? But the law of large numbers says that there's a difference between, write this down in your notes. There's a difference between what's called experimental probability and theoretical probability. Theoretical, with one L, probability is what should happen. You all know that you should have gotten 0.5 because there's heads, there's a tails, there's a 50-50 shot. You should have gotten 0.5, but you didn't, and I didn't. We all were off. Experimental probability is what did happen. Theoretical probability is what should have happened. But the law of large numbers says that even when you're doing experimental probability, if you do experimental probability enough, eventually what happens? They get closer. Yeah, they get closer. So when you just did one experiment in your one little group and you were way off, but when you put the whole class together, it becomes even better, right? In fact, if we look at what my first period class had for an average, this was my first period class. This is what they had. They got 49.83. What would happen if we averaged your class with first period's class? Let's figure it out. 0.4983, 0.4983 repeating. Plus, what did we get? We got 0.53 plus 0.53. Divide by 2, and you get 0.51. Is 0.51 and even closer to the theoretical? So yeah, like Thomas was just saying, the more and more you do experimental probability and theoretical probability become closer and closer and closer. This is why people make a lot of money on gambling. Who makes money on gambling? No. The house. The house. Who's the house? That's the owners of the casino. Why do the owners of the casino make money? Because they know that the probability of you winning is 0.495. And I'm just making that up, but they know that the probability of them winning then is 0.505, right? Does that make sense? So let's say you show up. Is it very possible with a probability of 0.49 of you winning that you win? Absolutely. Just like it was very possible that Foster's group they won. Like if this was a casino, they won, right? Who lost? These poor people here, they lost big, right? But the casino owner knows that over time, these experimental probabilities are going to merge into the theoretical probability. So they set up the game so that it looks like you got a pretty good chance of winning. But who wins in the long term? They do. If you get $10 million bet in your casino, but you make 0.5% on every $10 million, what's 0.5% of $10 million? $50,000. So let's say you got a really big casino and every day you get $10 million bet in your casino. How much money are you guaranteed to make every day? $50,000. You make $50,000 a day. They know that because that's the law of large numbers. So if you go to Las Vegas, you'll see these huge buildings that are sparkly and glittery and their lights are on all night. And those are there because people went there and gave them $50,000 a day. Now, did some of them leave with money? They absolutely did. But overall, the owners of the casinos know that if they set it up so that theoretical wins out over experimental. All right, so what would my equation be? My equation here would be y equals, how many did I start out with? 60, and I start out with 61. Yep, I started out with 61. And then I'm going to multiply by what mine was 0.45, right? And I was raised that to the x power. T power. Thank you very much, to the t power. All right. Why am I not, like we did yesterday, going to have you make predictions about what happens later on? We already got to 0. Are we going to get any lower? No. And mathematically, this graph that we graphed here, is it ever going to get to 0? No, mathematically, it's never going to get to 0. In the real world, did it actually get to 0? And that's why you stopped. Exactly. All right, now let's look at problem 21. It says redo problems 11 and 20, but use exponential regression function on the calculator. All right, let's do that. Do you remember back in, I think it was maybe September or October, I would give you a graph and I would put a bunch of dots on it and the dots would look like this. And I would ask you, does it look like that has a positive, a negative, or no correlation? And you all said positive. How come you said positive? Goes up. In fact, then we figured out how to make a linear regression line that really closely matches that data. And we figured out even what that was. We started out doing it the hard way, kind of like we started out doing this the hard way. But does your calculator have the ability to find that line? Do you remember what button we hit? Different button. Not different button. Stat. Hit the stat button. By the way, before you hit stat button, everybody do this for me. Hit second, go back to your original screen. Hit second and then memory, because I want everybody to start out with a nice fresh calculator. Hit second memory, then hit 7 and then 1 and then 2. Everybody do that to start out, because that way we'll all start out with a nice fresh calculator. And those people from the previous class won't totally mess up what you're trying to put in. All right. Okay, now hit the stat button. And what am I going to hit so that I can enter some data? Not calc, that calculates. Edit, I want to put the data in. So hit edit. And because you just cleared out the memory, everything should be gone. Now go back to, now here's what I'd like us to do. Since I want us to all have the same answer, we're going to use my numbers for this. Okay, so here we go. Enter the trial numbers in list 1. Why am I only going down to 5? That's how far I got, right? And then in list 2, I want you to enter the coins that I got, not because I want us to all have the same numbers here. So enter the coins that I got. And then make sure I didn't hit a wrong button, because I always hit a wrong button. It's really aggravating. But it looks like I think I did all those right. All right. All right, we would now like to do an exponential regression. That was strange, but I won't say anything. All right, we're going to do an exponential regression. How did we do linear regression back in September? We hit what button? Stat. Everybody do this now. Hit the stat button. And then, since we want to calculate something, what should we go to? Go over to calculate. Don't click 0. All right, now if we were doing a linear regression, we would have gone down to linear regression. We're not doing a linear regression. We're doing an exponential regression. So where shall I go now? No, 8 is linear regression. Where shall I go now? Do you see anything that says exponential regression? Which one? 0. Henry was onto something. So hit exponential regression. And now you'll get to a screen. And basically what the screen is saying is, would you like me to use list 1 for the X values and list 2 for the Y values? And I think that's a good idea, because that's where we put them. So you hit enter a few times, go down to calculate, and the calculator does some magic, and it will come up with an answer. And the answer that it comes up with for my equation, what should I have gotten for my equation? I should have gotten y equals 76 times what? Times what? 0.44 to the x. This is the best equation possible. We figured out this equation just by kind of taking an average and then putting in the numbers. By the way, which number did I get pretty close to? The initial amount or the ratio? The ratio, yeah, I got 0.45. The calculator says 0.44. That's pretty close. The number that I was off on was the starting amount. So now what I want you to do is go back to yesterday's data. We'll use mine. Don't use yours. Use mine. This is my data from yesterday. Don't worry about trying to find yours, because that'll take a lot of time and we don't have that much time. Go back and figure out. This was my equation from yesterday. I got y equals 2 times 1.37 to the t power. I want you to tell me, what should I have gotten? Do that right now, because this is what you're going to have to be able to do on the next test. I'll give you the numbers. You tell me the equation. So this is growth instead of decay. So type that in, see what you get. That's an excellent question. Everybody knows you're hitting what button? Stat. Hit the stat button. All right, we're trying to figure out what this is. So go into edit, and I've got these old numbers in there. Now, Ben asked an excellent question. How do I get rid of these old numbers? Here's how you do it. If you want to get rid of everything in list 2, go up and highlight list 2 like I've done here, and then hit clear and enter, and all those numbers go away. Then go over here to list 1, go up and highlight list 1 like I've done here. So hit the up arrow till the list 1 is up there, then hit clear, enter, and they're all gone. Now I can go ahead and enter my new numbers. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 7, 12, oops, not 2, 12. Somebody needs to be in charge of making sure I enter these correctly, because I usually mess something up. Somebody make sure I did that right. But you would think finding an exponential function is way more difficult than finding a linear function, but it's really not, because on this calculator, now tell me what buttons to hit. Stat, calculate, 0, go down to 0. And then I just hit enter until I hit calculate. And it says that I should have gotten y equals 1.64 times 1.33, if I round that off to the t power. This is what I should have gotten. Did I get pretty close yesterday? Yes. I was close, especially on the ratio. I think I did pretty good on the ratio. On the starting amount, I was off quite a bit, but on the ratio, I was off. Now, that will be one question on the test. Then the next question on the test is going to be this. How many pennies yesterday, when we were growing the pennies, how many pennies would you have on the 15th trial? Yeah, so tell me what you get. So type in, let's see, 1.64 times 1.33 raised to the 15th power. How many pennies? 118 pennies. See how easy that is? So it's just like what we did back in September. It's just that we're doing exponential instead of linear. Otherwise, now, all the fancy calculations your calculator has to do to make that happen are kind of complicated, but we don't even have to worry about them because we can just let the calculator do all the work for us, which is nice. Okay. Whew, that's it. No assignment for tomorrow. That's it. Just go put your calculators up. That's all.